Hello and welcome to this video where I'm going to solve a very tough and very different idea for a mechanics M1 question. So let's start by first reading the question and what we have over here. So first it tells me that I have two particles, A of mass 0.3 kilograms, particle B of mass 0.5, and they're both attached at either end of a light inextensible string. I know from this that my tensions, okay, on both sides of the string are going to be the same, and I know that the string itself has no weight, so no mass contribution or force contribution due to the weight of the string. It says that the string passes over a smooth pulley. Smooth pulley means that there is no friction between the string and the pulley. A is hanging h meters below B, which is being held at rest 3.2 meters above the floor. So B is 3.2 meters above the floor, and at rest means that UB is 0, or it started while it was having a velocity of 0. Both parts of the string are vertical. B is released and both particles begin to move. So B, since it's is heavier, is gonna move down, okay, and hence A is gonna move up. So B will move until it hits the floor, and it says when B reaches the floor, it remains at rest. So B will hit the floor and remain at rest, while A, let's say A is here now, when B hits the floor, A will have some velocity. So due to inertia, A will continue a little bit upward before stopping. Okay, so it says that A continues to move vertically upwards until A reaches its maximum height 6.2 meters above the floor. Okay? Ignore A resistance, calculate the velocity of the particles immediately before B reaches the floor and the value of H. Okay, to do this, this is a different type of question. It's a little difficult, so let's try and draw what we have over here. So this is particle A. Let's say this over here is the floor, and this is particle B. We know that the distance between A and B is h. We know that the distance between B and the floor is 3.2 meters, and basically that's it. So first of all, I want you to know that three things are gonna happen to A. At the start, A is gonna move upwards with an acceleration, and B is gonna move downwards with the same acceleration. Okay, so once B hits the floor, what's gonna happen? A is gonna be over here, right? So A is gonna move. So if B moved 3.2 meters down, A should have moved 3.2 meters up. And then after that, A is not gonna stop immediately. A still has some inertia, even though when the tensions are not even there are no forces acting on A except its weight. A has inertia, so it will continue a little bit upwards to move, so it will move over here. And the question told me that the distance or the maximum height of A from the ground when it continues to move for a little bit is going to be 6.2 meters. Okay, so we know that the black color is the start, red color is when B reaches ground, and the green color is when A reaches max height and stops. So V of A is going to equal 0. It stopped over here. So let's see how we are going to solve this. First of all, let's resolve all our forces. So we know that A has a weight of 0.3 G. Okay, and before that, let me just write 0.3 G over here. Let me name the distance between A and the ground Let's just name it x. I don't know what's this distance. Okay. Okay. So A has a weight acting on it and it has tension. B has its weight acting on it, which is 0.5 G, and has the tension acting on it. So let's resolve with the upwards direction positive for A, because we always, when we resolve, I like to take the direction of acceleration as the positive direction. So since acceleration is upwards, I'm going to take up as positive direction. So let me do my dynamics equation. Is going to be T minus 0.3 G equals MA, which is 0.3 times the acceleration. And let's now resolve downwards as positive for B. Why downwards as positive? Because when we are taking B in perspective, B is moving with an acceleration downwards. So the direction of acceleration is downwards, so I'm going to take my positive direction downward. So 0.5 G minus T should equal 0.5 A. So this is equation 1. This is equation 2. Okay, so let's try and solve these two simultaneously to get what is the acceleration. So let me rewrite 1 under over here, and let me rewrite it in this way. So negative 0.3 G plus T equals 0.3 A. And from here, I can add those two equations together because adding them will cancel my t, which is something that is helpful. So 0.5 G minus plus negative 0.3 G is basically 0.2 G plus t and t is 0 equals 0.8 A. So this gives me an A value of 0.2 G over 0.8, which is going to be 1 over 4 G meters per second squared. This is my acceleration. Right. Let's see the first part of the question. The question wants the velocity of the particles immediately before B reaches the floor. So it's talking about the V of A, okay, and the V of B when B just before it reaches the floor. So we know that we will need to use kinematics for this question. So let's start by using kinematics for A. So let's put A particle with this. Okay, so I know that the acceleration is upwards. Let me start by saying that I will take the upwards direction as positive. Okay, so I know that my UA was equal to 0. I know that my S, okay, since B hit the floor, B moved 3.2 meters. So if B moved 3.2 meters A downwards, then A must have moved 3.2 meters upwards. So I know that my S is going to be 3.2 meters in the upwards direction. What else do I know? I know that my acceleration is going to be acting in the upwards direction with a value of 1 over 4 G meter per second squared. And what do I want? I want my VA. So I want my velocity at this point. So I didn't mention the time, so I'm going to use the equation that doesn't have time, which is VA squared equals UA squared plus 2AS. So I know that VA squared is going to equal 0 squared plus 2 times acceleration, which is 1 over 4 G, times my S, which is 3.2. Solving, VA is going to equal the square root of 2 times 1 over 4 G times 3.2. This is going to give me a VA of 1 over 4 times 9.8 times 3.2. This is going to give me an answer of around 4 meters per second. This is VA, and it's supposed to equal uh, VB, because let's do the same for B, taking, let's say, down as positive. So we know that UB equals 0. S is 3.2 meters down, and down is positive, so it's positive. So A equals 1 over 4 G meter per second squared. and VB equals this. So I'm going to use the exact same numbers in the exact same question. So it's going to give me a VB of 4 meter per second as well. So now I know my 4A, and I know that initially A moved 3.2 meters. Type. Let's think about after B hits the ground and A moves momentarily, moves vertically for a little bit due to its inertia. So this part over here. Let's try and resolve that using kinematics. So when I'm doing that, my initial velocity is going to be the 4 meter per second squared that I got earlier, because here it's moving with 4 meter per second upward. So now, when this is my starting point, okay, I'm gonna take my u as 4 meters per second. So let's try and do the things for A again. So I know that my u, okay, let's take upwards as positive. I know that my u is 4 meter per second. I know that my v is equal 0 because I'm going to stop. I know that my acceleration, because there is nothing acting on here, because after B hits the ground, the tension is not there anymore. This part becomes slack, okay, and tension goes away. There is no tension. So I know that my acceleration is basically going to be the acceleration due to gravity, which is going to be negative 9.8 meter per second squared because it's acting downwards. And I want my S. I want to see how much did A move upwards. So what letter didn't I mention? Again, I didn't mention T, so I'm going to use the equation without T, which is V squared, so 0 squared equals U squared plus 2 times negative 9.8 times S. Solving for S, I'm going to move this to the other side. It's going to be negative 16 equals negative 2 times 9.8 is negative 19.6 S. So dividing S is going to be 16 over 19.6, which is going to give me an answer of 0.82 meters. And since it's positive, and my answer is positive, and I know that positive is my upwards direction, I know that it's displaced upwards with a value of 0.82 meters. Okay, so from here, I know that A moved, since it started, to the maximum height it reached, it moved 3.2 plus 0.82 meters. So total distance A moved is basically the 3.2 meters initially when the tension was there, and then plus the small distance it moved when it was moving due to its inertia. So it's gonna give you an answer of around 4.02 meters upwards. Okay, I know I know that my maximum height is 6.2. And this part over here, from here to here, is basically 4 meters. So I can get my x by doing 6.2 minus the 4.02 meters that I got. This is going to give me x, which is going to equal 2.18 meters. So I know that my x is equal now to 2.18 meters. The question wants h. I know that h is the difference between A and B, and I know from the ground to B is 3.2. So I know that this whole thing is 3.2. I know that this part, which is x, is 2.18. The rest is h. So to find h, I'm gonna basically do 3.2 minus 2.18. This is going to give me an answer of around 1.0 meters for h. This is the answer for this question. Please feel free to look at the previous videos, which are very, very important. Feel free to comment, like, and subscribe. Kindly, please don't forget to enable your notifications so you don't miss out anything. And feel free, as I said, to comment anything. Check the previous videos, and thank you so much for watching. Have a nice day.